So we are going to be working on 7b today, which is looking at composite and inverse functions. So this is from the Unit 3 and 4 methods textbook. So we did composite functions and inverse when we did chapter 1, but this is going into more detail now in terms of logs, sine and cosine, um, and exponents with e. So just a reminder of what we've already done. A composite function is a function that is created when the output of one function is put into the input of another. So just quickly, if I've got these two functions here, we are putting the x value of 3 into the first function. It then spits out 11 because 3 times 3 plus 2 is 11. So that's my output, which is my range of my f function. Then it goes into my next function, which is g. So this is where we have the output, which is range f, needs to fit into my input of which is the domain of g. So it needs to be a subset, and then it spits out the output of range, which will be 121 because we know 11 times 11 is 121. So this is a different way of representing it because we know the range of our f function is the same as it should be equivalent to the domain of g for a composite function to work. So let's have a look at this question here. Express each of the following as the composite function of two functions. So with this, we need to identify the outer function and the inner function. So the outer function I can quite easily see as being e to the power of x, and then that inner function is going to be what's happening in my power, which is 5x minus 2. So I've written them separately. I'm just going to double check what the domain needs to be. So we know we need to make sure we list out the domain and range, because we always start off with the inner function, and that the range of the inner function must be a subset of the domain of the second function, the outer function, and it fits, it's fine. Because of this, we can write the composite function for x elements of all real numbers. Let's look at the next one. We've got p of x is equal to cosine 3x squared. So straight away, my outer function is going to be cosine. My inner function will be what's happening in here, where I'm pointing, which is 3x squared. I'm doing the table just to check to see that relationship. So we always start off with the inner function, which is 3x squared, and we know the domain is all real numbers, but our range is going to be 0 to infinity. Now we can see that my range of g is a subset of my domain of f. So that means we can write it for going back to our original domain of our first function, the real numbers. So it is a composite function for all real numbers. Okay, so let's look at these two functions here. We have f of x is equal to 3x plus pi over 4, and g of x is equal to cosine x. So we're going to create a composite function. So we need to think about what is the inner function. The inner function is the f, and the outer function is the g. Straight away here, I'm going to look at drawing a table. So a table here is I've got my domain and I've got my range for both my functions. So for f of x, it is linear. That means it's all real numbers. For g of x, we know The amplitude is 1, so its range is -1 to 1. And of course, our domain is all real numbers. So again, if we think about this, we always start off with the inner function f, become real numbers, and R is a subset of the domain of G. So now I know this, I can then write the constant function where all I'm going to do is put 3x plus pi over 4 into my cosine where I've got x. So that becomes cosine in brackets 3x plus pi over 4 for all x elements for real numbers. The next part is we are going to describe the secrets of transformations by using Dr. T. Now, we can't see it in this form at the moment, so what I'm going to do is I'm just going to factorize out the 3. So to do that, I need to look at pi over 4, and I'm going to divide it by 3. So that's what I need to do to factorize it out. So that is going to give me pi over 12. If you've forgotten, we've got keep, change, flip. So that means that actually turns into pi over 4 times 1/3. So as you can see over here, I've just factored that 3 out, and I can double check and times it by pi over 12. 3 times pi over 12 is 3 pi over 12, which is pi over 4. So it's always good to double check just to make sure we haven't made any mistake. Now I can look at if I've got any dilation or reflection. There's no reflection here, but I do have a dilation. So that 3 means it's a dilation factor of 1/3, and it's from the y-axis because it's affecting my x value. Okay, the next thing I need to look at is, do I have any horizontal shift or vertical shift? Well, I've got nothing over here, but I do have this in my brackets here, the pi over 12, and that is a horizontal shift in the negative direction. Another way of thinking about it is, how do I make this bracket 0? X must be negative pi over 12, so I'm moving in the negative direction. The next part we need to understand is inverse functions. So an inverse function is like, I've got this point here and my x and y values are switching. So they have been switched, and I've got a reflection line through here, y equals x. So that should be -1 there. So again here, if I've got f of x is -1, 3, if I'm wanting to find the inverse, it's going to be 3, -1. So I'm just switching. Another way of thinking about it is with graphs. Now, what you'll notice with both of these graphs here, I'm only looking at x squared in terms of equal to or greater than 0. And the reason why is, to get an inverse, it needs to be a 1-to-1. If I look at a quadratic, it's not 1-to-1. But if I draw only a part of it, if I draw a line, it's only going to hit my graph once. So that's what I've done here. I've only done it for x is equal to and greater than 0. The other part that I've done is, what we can see here is, with the inverse and the function, it is always going to intersect each other on y equals x line. So be mindful of that. So let's look at this question. Let f of x is equal to e to the power of 2x, and g of x is equal to 1 over square root x, where x is greater than 0. So to start off with, I'm thinking about, what is my inner graph? My inner graph is going to be f of x. My outer graph is going to be 1 over square root x. Again, I'm going to straight away put everything into a table, my domain and my range. So we know with f of x, um, I'm, my domain is always going to be all real numbers. And for an exponential, it can't equal 0. So it's going to be all positive real numbers for the range. Likewise, the outer here, I can't have a negative here. And I can't divide by 0, so it has to be all positive real numbers. So I can see straight away that the range of f of x is a subset of the domain of G, which means there is a composite function. So the first thing I'm doing is making that composite function. All I'm going to do is grab that inner e to the power of 2x and put it into my outer where x is. The next step is inverse. So all I'm going to do is change my x to y and y to x. Now we need to do some algebra to get y by itself. So the first step I'm going to do is just square both sides. If I square both sides, 1 squared is 1. The square root goes away and I get x squared. Now I'm going to times by e to the power of 2y. So I've got rid of my fraction. I'll put it back and get x to the other side. Now I can use my log. So because we're dealing with exponents. So log base e, 1 over x squared is going to be equal to my exponent. And finally, I can divide by 2. So I've got to this point, but it still looks a bit messy. So this is where I'm going to get my exponent to be a negative. Now we can use our power rule by grabbing that -2 and putting it out the front. So that really turns into -2 times a half equals -1. So we can write it as negative log base e x, where x is greater than 0.